Hey guys, welcome back to the WeeW Electronics. So we are in the tutorial for the STM32F1 and we are continuing in working on the UART connection. So in the previous tutorial we have been looking on the UART itself, and we made a library for initializing the UART, and finally we create a library for a receive and transmit. So today we will finalize our library by adding the interrupt activities, and also by putting the final strategy how we will be handling the whole UART on itself. Good. So before starting that, I would like to go through a little bit of theory. This is that we will explain the code that I will be writing later on. So just quickly, within this graph, the first graph is showing how a normal the main thread is working for a microcontroller. So we do have the main activity starting, and then we initialize most of our function. After that, the microcontroller goes within the normal activities, and then we do have the ISR, or interrupt service routines, which are happening. And one of the rules that I quite which is really common and must be respected is to have your ISR as short as possible, which means that you should not go with a loop or a while or a for inside your ISR. So the one rule in the code that we will be writing is to put as less as possible code and let the main thread managing it later on. So the longer is your ISR, the more you affect your own real-time system. So you should be quite careful about this activity. This is in general, and we will going to apply this within our next example. Great. Next is about the scenarios where we are dealing with the communication for the UART. So we do have usually a communication between the microcontroller and another device, a PC, and the microcontroller just processes the input and sends some output to the PC, which is the first scenario and the most basic one. The second one, there is some chances that we need to use the microcontroller as a bridge between two devices. Maybe they do have a different baud rate, or just because we don't have the material to bridge between both devices. So this is a way that the microcontroller is just a bridge, just taking data and sending it back. And the final and the third case is a mix of both. It's a bridge, but it processes some data between the two other devices. Good. So based on this two principle, we are going to start doing our code. And before also jumping to our code, just to introduce the hardware I'm using this time. Nothing new, but what I'm bringing here. So I'm bringing two FTDI. So this is the FTDI connected to the UART3, and this FTDI will be connected to UART2. And just for the information, the UART3, the UART1 on this blue pill is used for the USB connection, not the UART-USB, but the USB connection, so it will not be possible to use it as a UART communication with a PC. This is said, what I have put on place too, I prepared two HTML windows. So the COM11 is connected to the UART3, and the COM3 is connected to the UART2. Quite ironic. So we will try to proceed some connections and try to make let me clear the transmitter too, so to have a very clear data. And so we will try to make connection between both UART and see how the microcontroller will react by having sending from UART3, UART2, processing, and then send back to the UART3, and on the other hand. Okay, great. So let's open our program, and our program here is we are getting back to where we ended last time. And before jumping furthermore, I would like to add one function called void UART send, and this function will be sending a whole string, because the UART-TX that we do have now is just sending only one char. So this one we have to specify which UART, so unsigned short called UART, and also we have to have a char and we call it string. Okay, so good. So this is our function here. It will be quite simple. So what we will be doing, we will take an integer e equal 0, initialized at 0, and then while str of I is different from the null character. So the null character is the last char on the string, okay, which is this one. Just a moment. So I probably, I always do this here. Okay, now, yeah, and I don't have to put this here. Okay, while this is not the null character, what I have to do, what I will keep doing, is putting that I'll be sending, so UART-TX for the certain UART, and sending the str of the char in the position I, sorry. Okay, and then increment I++. Okay, here I have to close this one. Good, so now I have a ascending function, so let me declare it here on the top and put like this, and let's give it a try. Let's have a string, so a char of, call it message, and we will put 30 char. We can like use only 20, but I'm putting 30 just and called welcome to the WeeW. Okay, and here let's use for both UART 2 and 3. So this one UART 3, and we'll be using this one and this one. Let's use 9600 just to check if whatever the board we are using, there's no issue. Yeah, and another point, after sending the char, always put some delay. 1 millisecond is more than enough. Okay, and so we initialized both UART. We put here a delay of 100 milliseconds. Why? Because the registers needs a bit of time to get ready for sending. And finally, so we go here and we use our new wonderful function. Okay, so let's send through 2, and we put message. Of course, yeah, message like this, and let's then put here for 3. Okay, so now we do have a code that will send the whole message to the to both both comms. So let me put, so the COM3, which is UART2, should be at 256,000, and this one, so let's disconnect, connect, and the UART3 is at 9,000, disconnect and connect. Okay, so let's save, let's build, and let's run. Okay, we do have now our system sending to both the UARTs without having any issues, so that's quite wonderful. And we can jump to the next step. So for the next step, let's start putting the interrupt routine. So we go to the UART library, and the UART for the interrupt will be inside the initialization, which is exactly here. So inside the init, and we start here. So for it will be, we will be repeating the same thing, same each time. So it will be disable IRQ before to start all the setup. And I need to open and check here. Where is it? We have to go for the UART and look for the bit register related to, yeah, this is the UART. Where's the UART? Just universal. Probably, yeah, this one. And go to the registers. Probably you start looking for the control register. They are always hidden here. And like not parity selection. This one is clear by software. Nope, not this one. Yeah, this is the transmit interrupt. This is transmit complete. Okay, and this is clear generated. Yeah, this is the one. So this is the interrupt, the bit related for the interrupt, and that's a bit number 5, which means it's from hexadecimal point is 20. Good. So we go to the control register, UART1 and control 1, and parallel and equal to 0x20. Perfect. So after that we have to enable the NVIC. Yeah, the NVIC, I have to remember this one, enable, and then IRQ, interrupt request. Okay, and after that we have to put US. So if you look for this one, if you have any doubt, each time you run your system, this window is open, and here you can see all the routines, the interrupt routines, and this is here, so you can see the name like this. So you just copy UART1 and go back here to make it easier. IRQ, oh no, sorry, not handler, but IRQN, which is, should be, just a moment, I don't remember, I think IRQN, but that's the one, the correct one, because I had to do some research to find it, but IRQN. But after that, when you run the function, is the IRQ, the one I shared with you. Okay, and enable IRQ. Okay, so this is for the first one. Let's, even we don't need the UART one, but just let's have a clean library that we can use later on, or whatever the other board. So this one is 2, and this is 2. So, and the last one here, and this is 3. This is 3, and we almost finish. So we have to add just the disable IRQ here, and here we are. Perfect. So this is fully done. Okay, good. So let's save. Okay, no error. That's good. So now we have created the IRQ situation. What we need to do now is to work on how to manage inside the IRQ. The idea. So let's go back to the slide. First, I would like to choose if it's a bridge or it is a process or a bridge, and that's the first one of the first thing I would like to confirm. And the second one, if it's a process, because if it's a bridge, I'm just taking this data and send it immediately, so it's quite simple, and getting back to the previous example we have made. But if it's this situation or this situation, we need to clearly specify what kind of activity we have to do. So what we are going to do now is to have a function. Okay, I have a space, so a function that first, like the first step will be, I put here 1, I can't write here, so okay, let's go back. So if I put so 1, define my which UART I'm using. 2 is to confirm if is it a bridge or process or both, and after that will be if a process, then we need to go on, like we will need a string to fulfill, and also a counter to count the how we are fulfilling the string, and a signal to say that my string is ready. So that's the variable I'll be needing. So let me go first and declare the variables. So the first one is to use, so let me, okay, so the first variable I'll be putting is a string that I will be use. So USART, call it 1, USART 1, and then message, for example, and I put 250. I will put a big string, and this is to cover most of the case if I do have a longer one, but I will not be using it all the time. It's just for safety. The next one is unsigned short, which will be USART 1, and that will be the count. So this is the one we'll be counting inside the string how much have I been making new ones, and so I will put it as a 0, initiate at 0, and after that I will copy the same again. So for this one I will call the signal and also 0. Here I put it signal, and finally bridge. Okay, so this one will be like the initial setup here, and after that I will add for the 2 and the 3. 2, I hate when I do like that. 2 and 2. So I hope it makes sense for you guys now. I think when we will start writing the program right after putting this, it will make much more sense for you. 3 and here 3. Okay, so I have all my variables ready. Pardon me. And let's go back to the function. So as we said, the function that we need to write is kind of a void. So let's call it UART interrupt, or UART-USART to make it short. So as usual, unsigned short will be the UART, which UART I'm using right now, and then another unsigned short, which will be the bridge. Okay, am I bridging or not? And after that I will need, because I'm changing it for the signal, so unsigned short, but it will be a pointer for the signal. And finally also another pointer, unsigned short, it will be for the count counter, and we're good. Okay, so let's check. So the first thing, if my bridge is equal to 0, what does it mean? It means I don't need to send directly the data, and I need to process it. Okay, so if my bridge, so it means I don't have, so I need to start loading the data inside my string. So so what did they call it? Yeah, I forgot also to add the string. So here the last one is char of str, and let's put like this. Good. So what we will do, so the str of the counter of the pointer for the counter, so it's the initial value, will be equal to so UART RX of the UART, so the UART I would like to receive. Okay, good. So now I'm getting the information, and even I need to get another if this one, the string of the counter here, if this one is equal to terminator new line. So this is something you define as your strategy of receiving messages, but usually the new line terminator is quite universal and used in a lot of documents. Okay, so if your string is equal to terminator, if this is the last char you are receiving, so your counter will be equal, your counter should be equal to 0, and your signal saying that your message is ready and you received everything, signal should be equal to 1. Okay, signal, yeah, signal is equal to 1. Else, if it's not the last digit, so what you have to do here is incrementing the counter by 1. So waiting to receive the next char. Okay, this is in the case where we need to process. So if we finished all the reception, we go to signal 1, and it means we go to start processing what do we have. Else we increment the counter and we wait for the next information. So this is if we do have the bridge. Good. So then here we go to the else situation. Now we are bridging. I think I made this word, so maybe it's not that legit. So as we are bridging now, so it's quite simple, it's direct forward. So it's UART, UART TX. So I'm transmitting from the bridge that we need. So the one bridge to the UART receive. Just a moment. UART RX of the UART. Okay, hope that makes sense for you. So if I'm just, I think, yeah, forget the parentheses. Good. So if I'm bridging, or if I'm not bridging and I need to process the data, I'm putting bridge is equal 0. And if I'm putting another number for the bridge, and what would be the UART number, I will be directly bridging the data. Good. So let's save. Let's take this function and declare it in the header. Save here. Fantastic. Good. So we are coming back here, and let's start putting our the interrupt function. So we said let's go back here, and we are using the USART this one, 2. This is now where we use it. Okay. Okay, and let's take the function we have been using here so far, and we will start using it. Okay, here. So in the UART, for example, this is UART2, so my UART is 2, and my bridge, so if I would like to bridge, I have only UART3. This is where I send if I need to have a bridge. My signal is this signal, which is 0. Okay. My the counter, okay, it's here, and I almost made a mistake. So the counter should be this one, and this one should be 2. And finally, my string is this string. Okay. And I don't need the 250. Let's write things correctly. So there is a mistake here. Oh, of course, I need to put it as a pointer. That's something wrong. Okay, so now we prepare this one. Okay, and instead of this we put 3. This one will be 3. This one will be 2. And from here on it will be 3 everywhere. Okay, so now we have our function. Let me take this send function to the library, so we get rid of it. Okay, Control X, and we put it. Okay, let's save, and let's take this one too. This one. Let's take it to the end. Okay, so now we are ready to save everything and to check if, okay, I have 2 warning. So which one? The UART drive, this one is ending yes. Save, build. Okay, no warning at all. Okay, good. So now now as I made the interrupt, I should be able to get rid of this. Okay, and when I will send informations, as I am putting a bridge now, I'm not getting any data. I don't need to do anything. So now I'm in the bridge mode. So when I receive from UART2, I'm directly sending to UART3. On the other hand, if I receive any data in UART3, I'll be directly sending to UART2. So let's align. So we need to have, let's start first the case where we have the same baud rate for both. Here and here. Let's align also here. Okay, so let's clear everything. So we are quite ready for both of them. So let's save again, build, send. I'm receiving my information. Okay, so let's try now from UART2. Hello, and I'm receiving hello. Fantastic. Hello, I'm receiving another one. So welcome to the WeeW. It works. And the other side, you are welcome. Yeah, you see now, so we are quite bridging without having any program in between. And it's quite a very efficient, very short activity. So if we go back again to the UART and we go back for this function, we can see that it checks the bridge is not 0, so we have something, and immediately move the chars from here to here. So we are not losing any time, and it's quite very short without messing with the main thread. Okay, so that's quite good, but let's change a little bit here and see if we don't have the same speed. Let's say this one is okay, 28,800. So the UART3 is 28,800. Save. Okay, so let me clear again to have a beautiful, nice and empty screens. So let's run. Okay, so we are receiving and both are aligned. So if I put here hello, I'm receiving only the H. And if I say here welcome, just a moment, welcome, for example, so it arrives. And you know why? This is because this one is much faster, so it has less issue to get the data. So now what we have to do is to go, now we can't bridge anymore as we have some discrepancy. So what we need to do is to make some processing inside the while, and here it becomes really interesting. So the loop will be always running, but putting, so in the case of if, and we go to UART signal 2, as you remember is equal to 1. So you remember here when we finish processing, when we do finish processing the whole sentence, we have a signal equal 1, and this is a counter, so it becomes number 1. So just to confirm, I'm putting that. Yeah, this is very important, as I told you. And this here, just let me open this here. Okay, when I send my message using the HTML, I'm putting on enter to send this one. This is my terminator, which is /r/n, and this is to keep the function, to keep my program understanding there is an end or a new line coming. Okay, so if signal equal to 1, it's really simple. So because now I do have my sentence ready, my string ready, which is this string, this one. So what I would like to do now is just getting and sending it, which is UART send. Okay, and it will be 3, and after that I put my what I need to send, which is the UART2 message. Okay, but I still after that have to put the UART signal, this one equals 0, equals 0. And there is another step, a very important one that must be respected. That step is about making this UART fully empty. So I will create a function, a very simple function called void str empty, and it receives a char of just str here. Okay, so within this one, so we have an int I. It's almost the same logic here. I will copy to just not waste time. So instead of doing all of this, we just took the str will be equal str of I. Here it will be equal to the null character. So then my string is initialized again. Okay, good. So I have the str empty. Let me put it also here. Yeah, I know. Okay, here it's clean. Good. So str empty. So str empty to my message, so to keep it clean and initialized again. Other solution is to directly add this function to the send, but I don't recommend, as we can still need to keep the sentence, so better to have it in a different a different program. Okay, so now this is if, and after that we add a different if here. If 3 is equal to 1, so we send to 2 the UART 3, and the signal for 3 is equal to 0, and I'm cleaning the whole STR, the message for the UART 3. Okay, so now we do have, and yeah, we have to get back here, and we're not bridging anymore. We are going to 0. So we need to process, we need to do something with the sentence and send it back. Okay, let's save and build. Okay, no error, no warning. So let's reset and reset, checking that my program is sending with the right terminator. So clear and clear and clear here, clear everything. So let me add, so let's be here, let's add the terminator. Perfect. So just do, okay, so if I say here hello, I'm getting the right how are you, just to see. Yeah, you see now, so now I can send the whole message without any problem. So I am WeeW. Okay, there's an issue here, something, yeah, when it's WeeW it's wrong. Okay, so the message is not sent, something is not correct. Let me check. The 8000, this is correct, sending is correct. Let's check something here. Okay, it's not sending. So if it's not sending, let's try to go and debug and check what's happening. So let's debug. So we have to stop here and see. Let's see the UART 3. Okay, so it was working here. So UART, of course, that's a mistake. So we have to put signal for UART 3 here. Okay, let's save and reset. Clear, send. Okay, I put hello WeeW. Yeah, and it's working now. So you can see, even with a different baud rate, with a different, you can now have using the interrupt without really impacting your mainstream. So within this function, you just give a signal to the mainstream to do some job, and even the reception, even you are sending a very long sentence, it will not affect the performance of your PC. I need to take a very long sentence, for example. This one is a bit too long, but let's take this one, for example. All this, just to see. Okay, and if I send it, yeah, you see, it's a long sentence without really impacting the whole process. Okay, great. I think, yeah, the video is already a bit too long like that, but now we do have a really full program that can manage the whole UART without having any inefficiency in the program. In the next video we will still be working on the UART, but it will be an example, and we will be using the IoT small chip, the ESP1, as an example to see how we can use this library to efficiently have a communication with that chip. I hope you liked this video. Thank you a lot, and talk to you soon. Bye.